In this video, we're going to discuss how to construct frequency distribution tables. Now, frequency distribution tables are really important for taking a large amount of data, and we're going to do a simple example at first where we only have 25 observations, but you could take hundreds of observations and break it down into a table that you can easily view, maybe with only 10 different rows, right? 10 different things to think about as versus looking at 100 different observations, right? So it's a way to summarize, large data sets. Okay, so we have 25 observations of the number of hours of exercise per week. So we asked 25 different people how many hours they exercised, and they reported these numbers. Okay, we're going to construct a frequency distribution, so we're with only 5 classes. So we're going to use 5 classes. Now the number of classes will always be provided for you. So 5 classes, or sometimes classes are called bins. They're interchangeable terms. Okay, so we're going to take 25 observations of data and break it into this table here that will, capture that data in 5 different rows, so 5 different rows to examine as versus looking at all 25 data points. All right. So this is what a frequency distribution table looks like. It's not filled out yet. We're going to fill it out. But basically what we do is we notice, okay, our data ranges from, what's the lowest observation? Actually, I'm going to go ahead and copy this and bring it down. So what do we see? Let's see. What's the range of our data? The smallest data is 0. Looks like it's no hours of exercise, and the largest is 13. Okay, so we're going to take all that from 0 to 13 and break it down into 5 different groups. So 5 different classes, 5 different bins, and then we're going to count how many data observations fit into each of those 5 bins. Okay, so we've got to break down that range from 0 to 13 into 5 different bins, and then count the frequency. And that's what a frequency distribution does. All right, so let's go ahead and do this. There's basically 3 steps to doing it. The first is going to be determining the class width. Right, so like I said, we're taking data that ranges from 0 to 13 and breaking it down into 5 different classes. So determining class width, do this. What we'll do is we'll take the range and we'll divide it by the number of classes. Right, that will take the 0 to 13 and divide that amongst these 5 different classes. Okay, so in our data, the range, remember range is max minus the min. So the biggest number minus the smallest number. In this case, our number of classes is 5. So that'd be 13 minus 0 over 5, which is just 13 over 5, which is 2.6. All right, so our class width is 2.6. Well, actually 2.6, we should always round up what we find in the range divided by the number of classes. We should just round it up a little bit. And in this case, let's see, we want to round up to the next convenient number. So we'll round it up to 3, right? So convenient number to count by. Okay, so it's easy to count by 3. It's a little harder to count by 2.6, right? So you can always round up, never down. Up is definitely key. Always round up to the next convenient number. In this case, that would be 3. All right. So next, we need to determine the upper and lower class limits. Okay, so now we know that our class width for each of these classes is going to be 3. So now we need to determine the upper and lower limits for those classes. All right, so let's start with determining the lower limits. and then we'll go to talking about the upper limits. Okay, it's always easier to start with the lower, so you should always start with the lower. Now, for lower limits, we'll start at 0, which is our min. So always start with the smallest number, and then go to the next lower limit is going to be this lower limit plus the class width that you determined. Okay, so 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12, and that's all I need. 1, 2, 3, 4, 5, right? I have 5 classes, so I stop there with 5 lower limits. All right, my upper limit will go to the number that's right before the next lower limit. So the upper limit will go to the number that's right before the next lower limit. If you had data that consisted of decimals, so like say people reported to you that they exercised 2.5 hours, then you would want to take the number that's right before 3, so that'd be 2.9. Right? But because our data doesn't involve decimals, people only reported whole numbers for the number of hours that they exercise per week. I can just take the number that's right before 3, which would be 2. Right? And I can take the number that's right before 6, so that'd be 5. Right before 9, so that'd be 8. Right before 12, be 11. And then for the last class, I can think of, well, what would be the next class? The next class, 12 plus 3 is 15. So right before 15 is 14. All right, so these are my class limits: 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14. So once I have this, I'm ready for the last step, which is to just go ahead and construct your frequency distribution table. So let's go ahead and write in those class limits that we just calculated. 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14. Right? So now I just need to tabulate how many observations are between 0 and 2. All right, let's go ahead and find those. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 observations between 0 and 2. How many observations are between 3 and 5? All right, so let's see. 1, 2, 3, 4. How many observations between 6 and 8? 1, 2, 3, 4, 5. Let's see, I didn't cross that one out, so that should have been here, so that 4 should really be a 5. All right, that 4 should have been a 5, because I missed this 4 here, so, okay. Okay, between 11 and 9, sorry, between 9 and 11, 9 and 11. Oh, you know what, I missed that 7 as well, so this should have been a 6. Gotta be real careful when you're tabulating these that you don't miss any numbers. So that should have been a 6. Miss anything else? No. Okay. So between a 9 and 11. Okay. So 1, 2, 3, 4, 5. Okay. So that's 5. And then between 12 and 14, just 1. Okay, so you can double check that you didn't make any mistakes like the way I did, miss any numbers. So what you should do is you should add up these numbers. So 8 plus 5 plus 6 plus 5 plus 1, and you get 25, which is the total number of observations in your data set. And so you should always kind of double check that the total number of observations in the data set matches the frequencies that you reported in your table. Okay, so now that once you have this frequency table, then you can answer questions like how many people exercise less than 5 hours, you could say, oh, okay, well, less than 5 hours, that would be between 0 and 5. So I can add up these two, and I could say, oh, well, 13 out of the 25 exercise less than 5 hours. So you can answer some pretty interesting questions using this simple table. In the next video, we're going to talk about, expanding this table, talking about not just class limits, but class boundaries and class midpoints.